So the second problem of the backpropagation neural network. So the problem is like this: find the new weights. Find the new weights using backpropagation network for the network shown in the figure. Okay, and there is one diagram is given, right? And the network presented with the input pattern -1 1 and the target is +1. So target is given as 1 +1. Now use a learning rate of 0.25. Use a learning rate of 0.25. That means this alpha is given, okay, and this alpha is what? 0.25, and the bipolar sigmoidal activation function. Bipolar sigmoidal activation function. So we have to solve this particular problem. Let's see the structure also. So structure, all of you can draw. The structure is like this. So in the diagram, if you see here, this is the output. Okay, from here the output will be taken and the target is given +1. So this is a T, which is the target, and that is 1. So from here the output is coming. Now on the output there is one bias, okay, and this is what? W0 equal to -0.2. So this is one bias is there on the output. Then if you see, there are multiple layers. So first this is the input layer, and this is the middle layer, and then this is the output layer. So the inputs are x1 x2. If you see, the x1 is -1 and this x2 is what? +1. And from x1 to z1 it is collected by y11, okay, and the weight is 0.6. From x2 to z1 it is collected via v21, okay, and v21 is what? -0.1. This is v11 0.6. This is v21, this is 0.1. And then from x1 to z2 it is connected by v12, that is -0.3, and from x2 it is connected to z2 by v22, that is 0.4. So I told you that if you are trying to represent the weights between input layer and the hidden layer, you must use this v letter, and then between hidden and the output you can use w, right? So vw. Then there is one bias. There is one bias on the Z1 hidden unit, and that is V01. Okay, V01, and this is what? 0.3, and one bias is there on Z2, that is VO2, and this is what? 0.5. So two biases are there on Z1 and Z2. Then Z1 is connected to Y by W1 is equal to 0.4. So this weight we are representing by W. W1 is 0.4, and then from Z2 it is connected to Y by 0.1. Okay, so all of you can just draw this. So this is backpropagation neural network, and it's multiple layer, right? Input layer, hidden layer, and the output layer. What we have to do, we have to first calculate how this net input is flowing in the forward direction, and we have to calculate the actual output. Then after calculating the actual output, we will have to see also the target. What is the target? Then we will have to calculate the error, and then that error we will have to propagate in the backward direction, right? And then the third phase will be what? To update the weights. So there will be some changes in the weights, right, because of error, and that we will going to updating through the weights, right? So there will be three phases. First phase is feed forward phase, in which we will calculate the inputs flowing in the forward direction, and then the second phase is calculation of the error and that back propagation of that error in the backward direction, and the third phase is to update the weights, okay, because of that error. So after this, the first step is we will see what are the initial weights which are given. So if you see the initial weights, we can just note down, so that for solving the problem it will be helpful. So if you see the initial weights, how we can write the initial weights. Let me start the pen. Epic pen. Okay. W0 is minus 0.2. W0 is minus 0.2. Okay. So now let's say, suppose we want to write with respect to this z1. Okay, with respect to this z1. So first we will write with respect to z1, then we will write with respect to z2. Now let's write with respect to z1. So we will see, we will just focus on this z1 unit. What are the different inputs which are coming near to this z1? So if you see here, this v01 is coming, v11 is coming, and then v21 is coming. So we can just note down this. So let's say v11, okay, then v21, and then v01, and we can write that. So let's say v11 is 0.6, then v01 is 0.3, v21 is what, 0.1, v01 is 0.3. So this is one input set. Let's say, suppose we want to write for z2. So for z2 we have to see what are different inputs which are coming to z2. So if you see here, this is coming, this is what, v12. Okay, we have to take the first this script, this subscript, and this one, and then the later one, this 2. So this is v12 I'll write over here. Then the next is this one is coming 2, so v22, and next is coming v02. So v02 we will write, and this is what, so v12 is minus 0.3, v12 minus 0.3, v.4, and v02 is what, 0.5. So this is done, the second input. Now we will focus on this particular y. So what are the different inputs which are coming over here? So let's write. First w1 is coming, right? W1 is coming, then this w2 is coming, and then this wo is coming. So we can just write this. W1 is how much? W1 is 0.4, then W2 is 0.1, and then WO is minus 0.2. Okay, minus 0.2. So this is done, this input. Then the target, we know target is given plus 1, right? Target is given plus 1 and alpha is given 0.25. So all the input data are ready. Now next job is what? To apply all these things and then try to solve it. So let's start this. So the first job is always just focus on the diagram and just list down all the inputs and everything, right? So that all the data must be ready. The x1 and x2 you can just see over here. This x1 is what? X1 is minus 1, x2 is what? X2 is plus 1, right? So these are also two. So let's start now. Okay. So now the first step. Okay. So the first step is we have to apply what? Activation function. Why activation function? Because if we just focus, this is our z1, right? This is our z1. So to this z1 there are three inputs are coming, right? Three inputs are coming. Now we have to calculate what is the net input at this z1. What is the net input at this z1, which we will represent by z in 1. Okay, z in 1. Similarly, we will also calculate the total net input at z2, and this we will represent by what? z2 in. z2 in. So first job is what? To calculate z in 1 and z in 2. Then after, once we calculate this z in 1 and z in 2, then just substitute inside the activation function. Like here the activation function they have given what? Bipolar sigmoidal function. Okay, bipolar sigmoidal function. So bipolar sigmoidal function is represented by this. F of x is equal to 2 upon 1 plus e raised to minus x minus 1. 2 upon 1 plus e raised to minus x minus 1, or you can also represent by this one, 1 minus e raised to minus x upon 1 plus e raised to minus x, right? If we try to solve it, if we try to simplify it, then you will get this particular expression, 1 minus e raised to minus x, 1 plus e raised to minus x. So whatever expression you can choose, and you just try to solve it. So what we have to do after calculating this z1 and z2, we have to substitute inside this particular function, okay, at the place of x, and then calculate the output of z1 and the output of z2. So this is our task. So let's say first we will calculate the z in 1, right? So z in 1 will be calculated as what? Total net input which is coming over there, and multiply by the weights. So if you see here the VO1, there is one bias like this, okay, VO1, and then this is V11, let's say, and this one is what? V21. So V21, and the weights are what? V21 weights is 1, and then V11 weights is what? It's 0.6, okay, and then this weight is what? 1 only. So now we can calculate, we can simply multiply V11 into 0.6 plus V21 into 1, and then plus VO1. Bias you can add, because its weight is what? 1, right? So if we try to calculate its bias is what? 0.3 plus x1 is minus 1, okay, x1 is minus 1 multiplied by 0.6, its weight, plus 1 into minus 0.1, and then you will get 0.4. This is what? Z in 1. This is what? Z in 1. Z in 1 is what? Minus 0.4. Similarly, we have to calculate Z2 also. So let's calculate this Z2. So if we try to calculate z2, z in 2, right? So z in 2 will be this way. Okay. So z in 2 will be VO2 plus x1 V12 plus x2 V22, and if you try to calculate you will get 1.2. Okay, 1.2. So we got z in 1 and z in 2. Now what we have to do, we have to just substitute inside z1 and z in the function to calculate z1 output. Okay, z1 is the output of z1 in hidden unit, and then the z2 is the output of z2 unit. So to calculate this, we will just simply substitute for z1, we will substitute inside the function z in 1, and for z2 we will substitute the z in 2 inside the function. So if we just substitute inside the function, you will get z1 as what, 0.1974. Okay, and then for z2 you will get 0.537. So these are the two outputs which we got of the hidden unit. So the initial structure was like this. This was z1 and this is z2. Okay, inputs are coming here, and then this one, and these two are going to y, clear, with w1 w2, right, and then there is one bias. So we got this z1 output, we got z2 output. Now these z1 multiplied by w1 plus z2 multiplied by w2 plus this particular bias. Okay, this particular bias will give you the total net input at y, and that will be represented by as what, y in. So now we will calculate what is the net input which is coming to y. So that you can calculate by this bias is what, w0. This bias is represented by w0. So w0 plus z1 w1. Okay, this z1 w1 plus z2 w2. So multiply this and you will get this point minus 0.22526. You can verify in the calculation. Okay, it may be wrong, but you can verify, right? So with the help of calci you can just simply go on calculating. So y in, you got this particular value. After getting this y in, now we will calculate what is the output of this y. Okay, what is the output of this y? So how you can calculate the output of y? Again you will have to substitute inside the function. So the steps are no, it's a somewhat in similar way, right? First you calculate the input, then after substituting inside the function get the output. Again for the output layer, okay, for the y layer, calculate the input, net input, and then calculate the output after substituting inside the function. So let's go ahead. Okay, so to calculate this y, we can substitute that y in the function, and if we substitute that particular values, you will get what, 0.112. So this is minus 0.112. This is the output of y, and the target, we know target is what, +1. Okay, target is what, +1. So there is an error, right? Error is there, error is present, and we have to calculate the error because target was 1 and we got the actual output. This actual output is what, minus 0.1122. So how to calculate the error? So I told you error is represented by the delta. Okay, and then we'll try to calculate, and calculating that error is much easier by just looking at the diagram. So I'll explain you that one, but before that what we can do, now we require the f dash of this particular value. Okay, so here we got this f of y in. Now we want what, we want f dash of y in. Okay, f dash of y in. So how we can get this? We can get this by simply this particular formula. Okay, so we can use this 0.5, then multiplied by 1 plus f of y in into 1 minus f of y in. Why this expression we got? Because here we are having this particular formula. Okay, this particular formula for this is what, bipolar sigmoidal function. So if you take the derivative of this particular, you will get this function, 0.5 1 plus f of y 1 minus f of y in, if we try to get the derivative of this particular sigmoidal function. right? Now in this particular function you just need to substitute f of y in, and if you substitute you will get this value of the f dash of y. So this is what, it's very simple, it's very easy to calculate the derivative of the function at every step. This is the specialty of this particular algorithm. The derivative, and to calculate the derivative it becomes much easier if the function is like this. So we got the derivative as what, f dash of y in as what, 0.4937, right? So we will going to use two different functions. One is unary sigmoidal function and one is binary bipolar sigmoidal function, and one is unipolar sigmoidal function, and for both you are having the different f dash of y in. So you can just try to remember that thing, okay, that formula. Now the next step is, so we are having y in, okay, f of y in, that is y, and we also have f dash of y in. Now our next task will be to calculate the error. Okay, so to calculate error, this is the formula, okay, this is the formula, 1 plus f dash of y in multiplied by f of y in. Okay, so we just simply, we will if we try to see the formula, let me show you the formula. So this was the formula, tk minus yk into f dash of y in k, right? So f dash of y in k, we can multiply this, and then tk plus y, tk minus yk, you can just substitute. That means the target minus actual output, and the actual output is actually the minus, so that's why this has come what, 1 plus, right? And if you try to calculate that, and here only one output unit is there, right? Only y is there. So the structure is like this. We are having over here, we are having this z1, okay, then we are having this z2, and then here we are having, this is y. So only one output is there, so that's why we will calculate only delta 1, okay, only one is there, so delta 1 we are calculating. So delta 1 we got. Now what we will do, we will calculate, so this weight is what, this weight which is coming over here, this is what, w1, and this is w2, and one bias is there on this, that is wo. So we will calculate the change in w1, change in w2, and change in wo because of that particular error. So the formula is very simple for calculating the error, right? By just looking at the diagram you will be able to do. The formula is like this: multiply with the learning factor, okay, so the learning factor over here is alpha, then whatever is the error, so here error is only one, that is delta 1, and then whatever input is coming to that particular output neuron. So if you are talking about this one, so z1 is coming, and if you are calculating for z2, so z2 input is coming to this y. So for w1, that is delta w1, what we can do, we will multiply by alpha, that is the learning factor, then we will see which input is coming. So z1 is coming, so let's multiply by z1, and what is the error, so error is what, delta 1, so we can multiply by delta 1. So this will become the formula for delta w1. Similarly, let's say suppose I want to calculate for delta w2, that is for w2. So for w2, just check z2 is coming to y, right? So z2 we will multiply, and then what is the error, error is what, delta 1, and then alpha, okay, alpha. So we can calculate w2. Similarly for wo, so for wo, what will be the formula, let's try to calculate for wo. So alpha will be there, okay, alpha will be there, and then there will be delta 1, there will be delta 1, and because the input is what, input is 1 only, okay, so input is 1 only, so final formula will be alpha into delta 1. So by just looking at the diagram you can simply calculate the change in weights of w, right? So w1, w2, and wo you can calculate. If you see here, w1 is calculated, and this is minus 0.027, then delta w2 is calculated, and that is 0.0737, and delta wo, which is calculated as what, 0.1373, right? Now, so this task is done. At the output side, the task is done. So we calculate output, then we found out the error we got a delta 1, then these two, by these two weights it was connected, w1 and w2, okay, this z1 and z2. So we calculated the change in weights of w1, w2, and this wo. Now this propagate in this particular direction towards the input side, right? So now we will calculate what is the net input error which is coming at Z1 and Z2, right? So that we will calculate, and then we will calculate the output of Z1 and Z2. Then after that we will calculate the change in weights of these weights which are coming to Z1 and the weights which are coming to Z2. So the idea is like this, right? So now first we will calculate what is the net input error which is coming to Z1. So that we will represent by delta in 1, okay, delta in 1, and one error we will calculate which is coming to Z2, that we will represent by delta in 2. Okay, so whether you understood, delta input 1 is what the error which is coming to Z1, delta input 2 is what error which is coming to Z2. So obviously this delta is coming, delta 1 is coming to Z1 and delta 1 is coming to this Z2, right? So to Z1 we will calculate as what delta in 1, and to Z2 we will calculate it delta in 2. So how to calculate? Let's calculate the delta in 1. So delta in 1 calculation is very easy, right? Very easy. How to calculate? We have to simply multiply the by the weights, okay, by the weights and that error. So here if you see, delta 1 is coming and the weight is what for Z1, I am talking about Z1. So it is connected by this W1, right? So what you can do, delta 1 multiplied by W1, you will get delta in 1. So delta in 1 formula will be what? Delta 1 multiplied by W1. Okay, this W1 which is connected. Either you can mark this as W11 or whatever, right? So and the second is what? Delta in 2. So delta in 2 will be what? Delta 1 multiplied by this W2, right? So you can calculate the total net input error which is coming to Z1 and Z2. So here it is calculated, delta in 1 is calculated, delta 1 multiplied by W11. So this is 0.5491 multiplied by 0.4, and this comes out to be 0.21964. And similarly delta in 2. So delta in 2 is equal to delta 1 multiplied by W21, and this comes out to be 0.5491. Okay, and finally, then after that we have to calculate what is the output. Okay, what is the output error of Z1 and Z2? So that also we have to calculate, and that easily we can calculate by using the formula, this one. So the delta, for example, here if you see delta 1 is what? Delta 1 is the output of Z1, output error of Z1. Similarly the delta 2 is what? The output error of Z2 in this backward direction towards the input side. So that delta 1 is being calculated as what? Delta in 1, that is the net error which is coming to Z1 multiplied by f dash of Z in 1. Okay, multiplied by f dash of Z in 1. The way we calculated f dash of Y in, right? Similarly we also have to calculate, once we calculated Z in 1 and Z in 2, we can also calculate f dash of Z in 1 and f dash of Z in 2, right? So that we will multiply and we will calculate delta in 1 into f dash of Z in 1, and that we calculate, and that will be what? Delta 1. Okay, so this delta 1 is the error output of Z1. Similarly for Z2, what we can do, we can multiply it by delta in 2, that is the input error which is coming to Z2, multiplied by f dash of Z in 2. Okay, f dash of Z in 2, and this is calculated, and it is what? 0.0195. So this is delta 2. So we got the error of Z1 output as what? Delta 1, and for Z2 we got as what? Delta 2. So once we got this one, we can use the similar formula which we use over here, okay, to calculate the change in weights of input weights of V, right? And that we can calculate. So let's calculate that one. If we try to calculate, if we see here, the formula is very simple. I told you, by looking at the diagram you can just try to calculate. So the formula is very simple. For example, if you want to calculate V1, the change in weights of V11, then the formula is very simple. Alpha, that is the learning factor, multiplied by delta 1. So that is the output of your Z1, okay, and then multiplied by x1. So x1 input is coming to that particular z1. You can calculate it's coming out to be minus 0.0264. Similarly, v21 change in, let's say v21, so that is what alpha into delta 1, okay, and multiplied by x2. So x2 is coming over there, and then you can it is calculated to be what, 0.25 into 0.01056 into 1, and that is